I'm going to provide an example of a homework type question where it says to completely factor a polynomial function. Well, we don't have an easy way to factor a quartic polynomial function, so we have to use our reasoning rules. So the first thing I'm going to do is I'm going to come up with my possible rational roots. So my possible rational roots are the factors of the constant term dividing by the factors of the leading coefficient. Leading coefficient is 1, so I'm not going to write the division symbol. My factors of 24 are plus or minus 1, plus or minus 24, plus or minus 2 goes with 12, 3 goes with 8, and 4 goes with 6. So those are all of my possible rational roots for this function. I'm going to use Descartes' rule of sign just to help me narrow down some information as I go through it. So for positive zeros, I just copy the sign of the coefficients. And I count my sign changes. 1, 2. So I'm either going to have 2 or 0 positive roots. For negative roots, I change the signs for my odd powers. Even power stays the same, odd power changes. Even power stays the same, odd power changes. Even power stays the same. And then count my sign changes. 1, 2. So I'm either going to have 2 or 0 negative roots. So I'm now going to use synthetic division with these numbers to try to find my first root. And I always start out using 1 and negative 1. I try to do the easy numbers first. So for synthetic division, notice I am not missing any terms. So my setup for synthetic division is to write down the coefficients. 1, negative 4, negative 7, 22, and 24. My goal is to get a 0 in that remainder block. So I said the first number I'm going to try is a 1. I try a 1, copy, multiply, add, negative 3, multiply, add, gives me negative 10, multiply, add, that gives me negative, that's a positive 12, multiply, add 36. A 1 didn't work. One thing I noticed as I was doing some of this multiplication is that when I got to this step right here, is if this would have been a 2, I would have ended up with a, if actually that would have been that 12, if I would have been multiplying by negative 2, that would have given me the negative 24, which would have allowed it to give me a 0. So what I'm going to do now is I'm actually going to try that negative 2 because I'm just using reasoning skills. Let's just try it. So copy again. And I'm going to try a negative 2. Copy, multiply, add, multiply. It's a positive 12, add, multiply, add, multiply, add. I did get a 0. So I know one of my factors is x minus 2. Because this is a negative number, the next thing I want to do is I want to check to see if it's a lower bound. And it went positive, negative, positive, but it didn't go negative here. So I can't say that the 2 is a lower bound. What this leaves me with is the polynomial function. That was x to the 4th, so this is x cubed minus 6x squared plus 5x plus 12. If I look at that polynomial function, I don't see an easy way to factor that cubic polynomial function. So what I'm going to do is I'm going to continue using Descartes' the rational root theorem and synthetic division to try to find another factor. What I've noticed here is now my trailing term is 12, so I know that 24 cannot be a 0 of this polynomial. Again, I tried 1. I told you I'd also try negative 1. So I'm going to try negative 1 in here because it's still a possibility. So I'm going to copy, which gives me a 1. 1 times negative 1 is negative 1. Add gives me negative 7. Multiply, negative 7 times negative 1 is a positive 7. Add gives me 12. 12 times negative 1 is negative 12. 12 minus 12 is 0. So I know that x plus 1 is a 0. And that leaves me with the polynomial function x squared minus 7x plus 12. This is a quadratic, and if it's one of those that you can factor by inspection, which this one is, you can write down the remaining two factors. Two numbers that multiply to 12 that add to negative 7 are negative 3 and negative 4. So I get x minus 3 times x minus 4. And that is the factored form of my original expression. So I used the rational root theorem. I used synthetic division. I was able to factor by inspection. So basically what you need to do to find zeros of polynomial function, or zeros and or factors of polynomial functions, is you have to use all the tools from your high school algebra, chapter 2 when we discuss quadratics, and our tools from chapter 3 of analyzing polynomial functions.